Alright, in my last video, I used OpenTofu, which is an open source fork of Terraform, to provision AWS Lambda, EventBridge, IAM roles, and CloudWatch. Check that out if you'd like to learn more about that. In this video, I'll be using OpenTofu again, but for a different kind of AWS project. This time, I'm starting with a static website that's hosted from an S3 bucket. The site's up, but right now it's only available through the default S3 website endpoint, and that's not exactly the cleanest URL to give to users. So the goal of this project is to take that ugly S3 URL and turn it into a more production-ready setup with a real custom domain, HTTPS, CloudFront, Route 53, and a private S3 bucket. By the end of this, the site will be available at meilissoapstore.xyz instead of the default S3 endpoint. Right now, the project is hosted from an S3 bucket as a static website. So I'm going to go into the S3 bucket, open the Properties tab, scroll down to the static website hosting, and click the bucket website endpoint. This brings up an early version of the storefront. It's going to be a simple e-commerce site that will eventually be used to sell soaps and plants. The site itself loads, but if you look at the address bar, the URL is not very user-friendly. It's the default S3 static website endpoint, so it has the bucket name, the S3 website region, and the AWS domain in the URL. That works great for testing, but it's too messy for something that I would want people to actually use as a real storefront URL. So the goal here is to take that ugly S3 URL and put a proper custom domain in front of it. And I want them to be able to visit the site through my domain using HTTPS. To do that, I'm going to use Route 53 for DNS, or Domain Name System, which controls where the domain points. I'll use AWS Certificate Manager, or ACM, for the SSL certificate, CloudFront to serve the site securely, and OpenTofu to manage the infrastructure as code. Before setting everything up, I want to give a quick overview of the architecture for this project. Starting at the top, the domain is registered through Namecheap. Namecheap is still the domain registrar, but DNS is handled by Route 53. Route 53 becomes responsible for resolving the domain, so when someone visits the domain name that I'm buying, Route 53 points that request to the CloudFront distribution. CloudFront is the main entry point for the website. It sits in front of the S3 bucket and serves the site to the users. This gives the site HTTPS support, HTTP to HTTPS redirects, compression, and global content delivery through CloudFront edge locations. For HTTPS, I'm using AWS Certificate Manager, or ACM. The certificate is created in US East 1, which is required when using ACM certificates with CloudFront. ACM validates the certificate through DNS. Route 53 contains the validation record that proves I control the domain. Before requests reach the S3 bucket, AWS Web Application Firewall, or WAF, can inspect them at the CloudFront layer. In this setup, I'm using AWS managed rules to help block suspicious IP addresses, common web attacks, and known bad inputs. Behind CloudFront is the S3 bucket that stores the static website files, like HTML, CSS, JavaScript, and image assets. The important part is that the bucket does not need to be publicly open anymore. Users can access the site through CloudFront instead of going directly to S3. To make this work securely, I'm using CloudFront Origin Access Control, or OAC. OAC lets CloudFront securely request files from the S3 bucket using signed requests. Then, the bucket policy only allows access from this specific CloudFront distribution. All this will bring the site closer to what I want for a real deployment. The first thing I needed for this project was a real domain name. Since the goal is to make the site easier to access than the default S3 website URL, I went to Namecheap and searched for the domain I wanted to use. And I decided on meilissoapstore.xyz. After seeing it was available, I added it to my cart. From there, I went through the checkout process. I'm not going to show you any private billing information here, but this is where I would review the domain name, check the renewal price, and make sure I'm only buying what I actually need. For this project, the important part is just owning the domain. I don't need Namecheap hosting because the website itself is going to be hosted on AWS using S3 and CloudFront. I'm going to manually create the CloudFront distribution in the AWS console so I can select the CloudFront free plan. Later on, this kind of setup can still be managed with OpenTofu, but since I'm creating it manually first, I would need to be careful not to accidentally create a duplicate distribution. So I'll click Create Distribution. For the plan, I'll select the free option. If the site ever needs more later, this can be upgraded. For the distribution name, I'll use Meili's Soap Store CDN. CDN stands for Content Delivery Network, and that's basically what CloudFront is. It sits in front of the S3 bucket and helps deliver the site more securely and efficiently. For the domain settings, I'm not going to add the Route 53 managed domain just yet. I'll handle the custom domain certificate and DNS setup later. For the origin, I'll leave it as S3. Then click Browse S3, and I'll select the S3 bucket that contains the static website files. For the cache settings, I'm going to customize them and set the cache policy to caching disabled for now. Later, when the site's closer to being finished, caching would be useful, but while I'm still making changes, I don't want CloudFront caching old versions of the site getting in the way of me being able to tell if my updates are working. For security, the free plan includes WAF protection. This creates a WAF protection pack with a name that starts with something like Created by CloudFront. Once those settings look good, I'll click Create Distribution. Since I'm still learning OpenTofu, I wanted to give it another try to get some more practice using it. I've already set up the OpenTofu project here. If you'd like to learn more about how to do that, check out my last video about it. For this project, an important step is importing existing AWS resources. Since I manually created the CloudFront distribution earlier, I want OpenTofu to take over management of the one that already exists rather than creating a second one. Tofu import allows me to add an existing AWS resource to the OpenTofu TF state file. As long as it matches the configuration blocks I have, the configuration will manage the imported resources. Before running tofu commands, make sure you are in the right folder where OpenTofu files are located. To import CloudFront, I ran the command tofu import followed by the resource address from my configuration, that being AWS CloudFront distribution.site, followed by the distribution ID at the end. I also imported the WAF Web ACL that was created with CloudFront by running this command. The part in the single quotes is the OpenTofu resource address. The first part of the resource address is the resource type WAF v2 Web ACL. Web ACL stands for Web Access Control List, and it gives you control over the web requests that your Amazon CloudFront distribution responds to. In this case, CloudFront is the resource name that I defined in my configuration. The rest of the command is the import ID. It's made up of the WAF Web ACL ID / the WAF Web ACL name / the scope, which indicates that WAF is being used for CloudFront. Now we'll look at some of the OpenTofu configuration files. Versions.tf handles the OpenTofu and AWS provider setup. At the top, the Terraform block defines the minimum required version and the provider this project depends on. In this case, I'm using the AWS provider from HashiCorp version 5. Then, I have my main AWS provider block. This uses var.aws region, which is set to US East 1. That matters because CloudFront uses ACM certificates from US East 1, so the certificate needs to be created there. I also have a second AWS provider with the alias bucket. This one uses var.s3 bucket region, which is set to US East 2, because the existing S3 bucket lives in that region. Both providers use default tags, which means the shared tags from my locals block are automatically applied to support AWS resources. So overall, this file is mainly about telling OpenTofu which provider to use and which AWS regions to work with. Variables.tf defines the configurable values used throughout the OpenTofu project. Instead of hard-coding values directly into main.tf, I define them here as variables. That includes the primary AWS region, the domain name, the existing S3 bucket name, and the bucket's region. It also defines the CloudFront price class, which controls how many CloudFront edge locations my distribution can use. It's currently set to price class all, which enables all locations and gives the best coverage. There's also minimum TLS version. TLS stands for Transport Layer Security. It's the modern security protocol used by HTTPS to encrypt traffic between the browser and the website. I also have the create WAF variable, which is also useful because it lets me turn the WAF on or off without deleting the code from main.tf, as well as a tags variable that could let me add extra tags to my resources later down the line without having to change my main code. This all makes the project easier to update later. For example, if I wanted to change the domain name or use a different S3 bucket, I could update the variable value here instead of searching through the whole main infrastructure file. This file keeps configuration cleaner, more reusable, and easier to adjust. Now I'm going to walk through the main.tf file, which is where the actual AWS resources are defined. At the top of the file, I define common tags in a local block. It merges the tags project, managed by, and domain with that tags variable from earlier. These tags get applied across the AWS resources in the stack, so everything's easier to identify when looking in the AWS console. Next is the Route 53 hosted zone. This is the DNS zone for the domain stored in var.domainname, which is meilissoapstore.xyz. This is what allows AWS to manage DNS records for the site, including the main website record and the certificate validation records. After that is an ACM certificate for the domain. The certificate is what CloudFront will use so the site can be served over HTTPS instead of HTTP. The validation method is set to DNS, which means AWS Certificate Manager will prove that I own the domain by checking for a DNS record. Since this setup also creates the Route 53 hosted zone, OpenTofu can create that validation record automatically. There is also a lifecycle setting called Create Before Destroy. That tells OpenTofu to create a replacement certificate before destroying the old one, if the certificate ever needs to be replaced. It's useful because it helps avoid downtime for CloudFront distribution. The next resource creates DNS validation record for the certificate. ACM provides the record name, value, and type that it expects to find in DNS. This block loops through those domain validation options and creates the matching Route 53 records. The for each is used because ACM can technically return more than one validation option, especially if there are multiple domains or alternate names on the certificate. In this case, it builds a map based on the domain name and then creates each needed record. The allow overwrite equals true setting lets OpenTofu update the validation record if it already exists. This is helpful when rerunning the configuration or working with resources that may have already been created manually. Then I have the ACM certificate validation resource. This doesn't create a new certificate by itself. Instead, it tells OpenTofu to wait until ACM has successfully validated the certificate using the DNS records that were just created. Once that validation succeeds, the certificate can be used by CloudFront. After the certificate section, I create a CloudFront Origin Access Control, or OAC. This is an important security piece. The S3 bucket for the website should not be public. Instead, CloudFront should be the thing that accesses the bucket. The OAC lets CloudFront securely request files from S3 using signed requests. The origin type is set to S3, and the signing settings tell CloudFront to always sign requests using AWS Signature version 4. That way the bucket can stay private while users still access the website through CloudFront. Next is the AWS WAF Web ACL. This has a quick check at the beginning to see if var.createWAF is true. If createWAF is true, OpenTofu creates the WAF. If it's false, it skips it. The WAF is scoped to CloudFront, which means it protects traffic at the CloudFront layer before requests reach the S3 origin. The default action is set to allow, so requests are allowed unless one of the WAF rules blocks them. Then I have 3 AWS managed rule groups attached. The first one is the Amazon IP reputation list. That helps block traffic from IP addresses that AWS has identified as suspicious or risky. The second one is the common rule set. This protects against a lot of common web attacks like bad request patterns or attempts to exploit common vulnerabilities. The third one is the known bad inputs rule set. That looks for request inputs that are commonly associated with malicious activity. Each WAF rule also has visibility configuration enabled. That means AWS can publish CloudWatch metrics and sampled requests, which makes it easier to see what the WAF is doing and troubleshoot any blocked traffic. Next is the main CloudFront distribution. This is the resource that actually serves the website to users. The distribution is enabled. IPv6 is turned on, and the default root object is set to index.html. That means when someone visits the root of the domain, CloudFront knows to serve the index.html file from the S3 bucket. The aliases setting connects the distribution to my custom domain name instead of only using the default CloudFront URL. The origin block tells CloudFront where to get the website files from. In this case, the origin is the existing S3 bucket built from the bucket name and bucket region variables. It also attaches the Origin Access Control created earlier, which is what allows CloudFront to securely access the private bucket. The default cache behavior controls how CloudFront handles normal website requests. I'm only allowing GET and HEAD requests, which makes sense for a static website because users are just downloading files, not submitting changes to the bucket. The viewer protocol policy is set to redirect to HTTPS. So if someone visits the site over HTTP, CloudFront redirects them to HTTPS. Compression is also enabled, which can help reduce file sizes for supported content. The cache policy ID being used here is AWS's managed caching disabled policy. That means CloudFront will not aggressively cache the site content. For a frequently changing static site, that can be helpful because updates from S3 are reflected more quickly. The restrictions block currently has no geo restriction, so the site is not limited by country at the CloudFront level. The viewer certificate block attaches the validated ACM certificate to the CloudFront distribution. That is what makes HTTPS work with the custom domain. It also uses that minimum TLS version from the variable I showed earlier, which lets me control the security level. Web ACL ID connects the WAF to CloudFront, but only if WAF creation is enabled. If create WAF is false, then this value becomes null and no WAF is attached. After CloudFront is the Route 53 record for the actual website. This is an A record for the root domain. Instead of pointing to a fixed IP address as an A record typically does, it uses an alias record that points directly to the CloudFront distribution. This is the normal AWS approach for connecting a root domain to CloudFront because CloudFront doesn't give you a permanent IP address to use. So Route 53 uses the distribution domain name and hosted zone ID behind the scenes. Next, I'm updating the S3 bucket policy using IAM policy document data source. This section creates the JSON policy that will later be attached to the existing S3 bucket. The first policy statement allows the S3 logging service to write objects into the bucket. This preserves the logging permission that already existed on the bucket. It also limits that permission to the AWS source account. The second policy statement allows CloudFront to read objects from the bucket. The principal is the CloudFront service. The action is S3 get object, and the resources is all objects inside the bucket. The most important part of this statement is the condition. It only allows access when the request comes from this specific CloudFront distribution ARN. The ARN is an Amazon resource name that can be used to uniquely identify an AWS resource. CloudFront can read from the bucket, but the bucket is not just open to the public. Finally, the last resource attaches that policy to the existing S3 bucket. This configuration doesn't create the S3 bucket itself, the bucket already exists, and OpenTofu is only managing the bucket policy. The provider equals AWS.bucket line tells OpenTofu to use the provider alias for the bucket's region. That matters because the bucket may be in a different region than some of the other resources. The outputs.tf file defines the values OpenTofu prints after the infrastructure is created. These outputs are helpful because they give me quick access to important information without having to dig through the AWS console. For example, I output the Route 53 hosted zone ID and name servers. The name servers are especially important because those are the values I need to copy into Namecheap, so my domain points to Route 53. I also output the CloudFront distribution ID and domain name, which are useful for checking the distribution in AWS or testing it directly before the custom domain is fully working. The certificate ARN output shows which ACM certificate is being used by CloudFront. And the website URL output gives me the final HTTPS URL for the storefront. This file contains all of the most important values I need after running OpenTofu. Now that the OpenTofu files are set up, I'll run tofu plan. This allows me to see in detail what OpenTofu is going to create, update, or delete. This is one of the nice things about infrastructure as code because I can review the changes before actually applying them. Then I'm going to run tofu apply. Before it makes any changes, OpenTofu shows me the plan again and asks me to confirm one more time. Once everything looks right, I confirm the apply. This part can take a few minutes, especially because resources like CloudFront distributions and SSL certificates are not always instant, so if it looks like it's sitting there for a little bit, that's normal. Once the apply finishes, OpenTofu prints out the outputs from the outputs.tf file, including things like the Route 53 name servers, the domain name, and the final website URL. After OpenTofu creates the Route 53 hosted zone, I need to connect my Namecheap domain to Route 53 because I want AWS Route 53 to handle the DNS records. So in Namecheap, I'm going to my domain list, click Manage on meilissoapstore.xyz, and I find the name server settings. That's where I can switch it from the default Namecheap name servers to custom DNS. And that's where I'll paste the 4 Route 53 name servers that OpenTofu outputted. After saving that, Namecheap will delegate DNS for the domain over to Route 53. This change usually takes some time to propagate, so the domain might not work immediately everywhere. But once the name server update finishes, Route 53 becomes responsible for resolving meilissoapstore.xyz. Now I'm going to click through the AWS console and show some of the resources that OpenTofu created. First, in Route 53, I can see the hosted zone for meilissoapstore.xyz. Inside the hosted zone, there are DNS records for the domain, including the record that points the domain to CloudFront, and the certificate validation record for ACM. Then, in AWS Certificate Manager, I can see the SSL certificate for the domain. This is what allows the site to load securely over HTTPS. In CloudFront, I can see the distribution that sits in front of the S3 bucket. This distribution has the custom domain attached, redirects HTTP to HTTPS, and uses the ACM certificate. It also points back to the S3 bucket as the origin. I can also see the Origin Access Control, which is what allows CloudFront to securely access the private S3 bucket. I can go to AWS WAF and Shield and see the Web ACL attached to CloudFront. This is where the managed security rules are configured to help block suspicious requests. And finally, in S3, I can see that the bucket that stores the static website files has the new bucket policy that allows access from CloudFront. Now that CloudFront's all set up and has permission to read from the S3 bucket, the bucket itself doesn't need to be public anymore. So I'm going to go into the S3 bucket permissions and make sure public access is blocked. CloudFront can still fetch the files from S3 because of the Origin Access Control and bucket policy, but the bucket will no longer be publicly open. Make sure to check Block All Public Access, then type Confirm. Now I'm going to test the final result. I'll type in meilissoapstore.xyz, and now the site loads through the custom domain. The big thing to notice here is the URL. It's much cleaner than the original S3 endpoint, and it also has HTTPS enabled. This was a good project for getting more practice with AWS infrastructure, DNS, certificates, CloudFront, and infrastructure as code. I'm Jeremy Harrison. You can find my LinkedIn profile in the description. I'm currently open to work, especially for roles related to software engineering, cloud engineering, AWS, .NET development, or infrastructure automation. Thanks for watching, and I'll see you in the next one.